Hello guys, and welcome to the final lesson of Unit 2, which is data transmission. In this lesson, we're going to focus on this term encryption, and we're going to find out how data is encrypted and why we need to encrypt data in the world of computer science. So like I mentioned, this is the final lesson in Unit 2, which is all about data transmission. And if you've missed any of the previous videos, just go back and fill in any gaps that you might have missed in this unit. So our syllabus topics that we're going to tick off today is to be able to understand the need for encryption and the purpose of it when we transmit data. And then we will understand how data is encrypted using these terms symmetric and asymmetric encryption. And we'll look at the differences between these two types of encryption. The term public and private keys we'll also understand the use of, and there are many other keywords that we need to establish so that we can answer a range of questions when it comes to encryption in any exams. So in short, we can imagine encryption as a digital lock that keeps our information safe and private. Obviously, there are many reasons why we need to keep information private, but the main reason being so that only the right people can see it. We don't want just anyone being able to see our information, especially if it contains private or sensitive information. So keeping information private is the main reason why we encrypt data. Stopping hackers. So although it doesn't actually stop hackers from stealing the data, what it does stop is the hacker from actually being able to see it. If data is encrypted securely enough, there's no way that the information could be read or understood by the person who stole it. It allows for safe online communication. So if we're communicating with people across the world, encryption keeps it private and safe, and especially going back to that term, sensitive information, credit card numbers, confidential information, all of these things need to be kept private. We have the element of trust. If you're buying things off a website, you want to know that you can trust this company, especially when you're transferring money to them, you're giving them bank details. We need to know that the information is being kept safe. And then finally, following the rules. Many laws across the world require encryption to be in place, especially when they contain information about people. So companies that store information about people, so schools, hospitals, governments, all these things, they have to follow the law, which requires them to encrypt data to make sure that it's safe. So it's quite simple how it works. We just need to be familiar with these certain keywords that I'm about to explain now. The first word I'm going to explain is plain text, which is literally the original message. So the message that's being sent or the data that's being transmitted is known as plain text. So this could be an email that you're sending. It could be, like I said, the bank card. The actual data itself is known as plain text. Now, obviously, we don't want plain text to be going around the internet because if anybody picks up plain text, they can read and understand it. So what happens is this plain text goes through what we call an encryption algorithm. Remember, algorithm is just a sequence of steps, a set of instructions. And these instructions will encrypt the data so that it's in some kind of unreadable format. The encryption algorithm is known as an encryption key. It will have a key to securely change this data into an unreadable format. Once it's changed into an unreadable format, this is called ciphertext. So we need to know what that means, which is when the data is completely unreadable unless you have the encryption key. This information then goes across the internet. Obviously, if anyone steals it or intercepts it at this point, it's still in ciphertext form and it should be unreadable, and any sensitive information can't be read or understood. On the other side, it goes through the same decryption algorithm using a decryption key and then is changed back into plain text. So with that in mind, I've mentioned here a couple of keys. We've got an encryption key and a decryption key. Now, depending on the type of encryption that takes place, will determine if these two keys are the same or not. And that's where we come to these two terms, symmetric and asymmetric. So the first one, symmetric, we can take the first three letters and we're going to remind ourselves that it's simple. Okay, symmetric is the most simple type of encryption. Now, the reason why it's simple is because it only involves one key. It's got one key to encrypt the data and one key to decrypt the data. Okay, the same key does both things. So although it's pretty safe in that it still uses encryption and produces what we call ciphertext, but there's only one key involved. And that key needs to get from the sender and the receiver. It needs to be here and here, before and after the encryption, which means the key to unlock it is going to have to be transferred either across the internet or sent via an email. It has to be transmitted in some way. So a hacker would only need access to one key. Once they've got that key, they can then unlock the ciphertext, decrypt it, and read the original message. So it's not as secure as what we're about to discuss now. Asymmetric makes use of two keys. The two keys involved, public key and a private key. Now, how it works can be quite confusing, so please bear with me during these steps. The public key is made available to everybody, okay? It's called public, so it's publicly available. Anybody can access it. And this is used to encrypt the plain text. Only the public key is used to encrypt it. Now, the private key is a matching set to the public key. Both keys are needed to encrypt and decrypt. They are linked in some way. This blue private key here is derived from the green public key. It can only unlock data that's been locked with this exact matching key. But like I've said, both keys are needed to encrypt and decrypt it. The blue key, the private key, is only known to the person who's decrypting the data. So that is kept safe and secure. It's kept private. So symmetric, only one key to encrypt and decrypt. Asymmetric uses two keys. It uses a public key to encrypt it, and it uses the private key to decrypt it. Public key made available to everybody. The private key only accessible by the person decrypting the data. A way you can think of asymmetric is a mailbox on the front of a house. If this is somebody's house, apologies for my drawing. We've got a front garden going down to this mailbox. So this mailbox, anybody can access this mailbox and post letters inside. Okay, they can put the letter inside because, as we can imagine, the address of this mailbox is public. Now, the only person who can access this mailbox is the owner of the house, who has the key for the mailbox to unlock it. Apologies for my drawing of a key. But again, only the person with this key, the secret key, can unlock the mailbox and read the letter inside. So that's a simple analogy if it helps you remember. Okay, but in terms of the GCSE exam, you just have to be able to describe the steps and the difference between symmetric, asymmetric, and the uses of the keys involved. So how an encryption key works, you can see in the example here. Here we have an encryption key of 42913628556. So that's going to be our encryption key. Okay, we're just working with symmetric for now, which means the same key to lock and unlock the data. What's going to happen is every letter in our message is going to be shifted across the alphabet to the amount in the numbers in our key. So the first letter will be shifted 4 letters across the alphabet, the next letter will be shifted 2, and so on and so forth. Our message that we're sending here, computer science is exciting, we will apply the key and encrypt the data. So as you can see, the first letter C is shifted across 4 spaces in the alphabet and is changed into the letter G. O is shifted across 2 places and is changed into the letter Q. So it keeps going and it produces what we call ciphertext. Okay, if you were to read this message, G, Q, V, Q, X, Z, G, Z, that makes absolutely no sense whatsoever. But as we mentioned, as long as you have the key, then you are able to unlock the text and go back to the plain text and understand the original message. Okay, but this is how a key works. So as you can imagine, these keys come in many different formats. They could include symbols, they could be really long, but the encryption key, the encryption algorithm, the more complicated it is, the more difficult it will be to unlock. So as we mentioned, symmetric is only one key, and obviously it's not as secure as asymmetric. Now, modern computers could, what we call, crack this encryption key in a matter of seconds. There's only one key, and it only takes a basic computer in 2025 to go through a series of keys and find the right one. There's only one to find out, and that's where asymmetric comes in and helps us out. Like we've said, asymmetric has 2 keys, a public and a private key. Public accessed by anyone and it's used to encrypt. The private key is kept secret by the receiver and is used to decrypt. So anyone can encrypt it, but only the receiver can decrypt it. And that's what makes asymmetric so secure. So again, just to show that in the diagram, we've got our plain text, okay, we need to become familiar with these terms, is locked using the public key and is turned into encrypted text, or better known as cipher text. Okay, this is the term that we want to start to use, cipher text. As you can see, this message here is completely unreadable and it makes no sense whatsoever. The private key, which is directly linked to this public key, unlocks the data and it turns the message back into what it was originally. And the receiver can obviously read the message, or at least make sense of the data being transmitted. And that's pretty much it for encryption, guys. As long as we can show understanding of all of these keywords here, then we're pretty much good to go in terms of encryption in the computer science syllabus. So if you want, you can pause the video now, quickly jot down the definitions, and then I will reveal the answers and then quickly summarize each one to finish the lesson. So there you go. Encryption, the process of encoding data in the way that it becomes unreadable. Asymmetric, a public key is used to encrypt the data and a private key is used to decrypt the data. Symmetric, the private shared key is used to encrypt and decrypt. The shared key, a secret key, is used to encrypt and decrypt. Public key, a key that anyone can see, and it's used to encrypt the data before it's sent to somebody else. And then the private key is used to decrypt the data. So these two relate back to asymmetric. Decryption means to decode the encrypted data back into plain text. Encrypt is to encode the plain text into an unreadable form, otherwise known as ciphertext. And then finally, plain text, the text hasn't been encrypted. Okay, so just being familiar with these terms, guys, puts you in good stead for any encryption questions in an exam, and just helps with knowing what encryption means, which comes up in various units across the syllabus. So if you missed any of the previous lessons for Unit 2, please go back and watch them, but that sums us up for Unit 2.